All right, chapter 6, section 3, factoring trinomials when there is a number in front of the x squared. Okay, the last section we talked about how to factor quadratic trinomials when there was not a number in front. Okay, which wasn't too bad. Let me show you a quick example of one. If I threw down x squared plus 7x plus 12. All right, it factors into two binomials. So you do parentheses, parentheses. And since the first term is just x squared, I knew this had to be x and x for the first term in each binomial. And then I need to figure out, hey, what multiplies to give me 12? Which there's three options here. 1 times 12, 2 times 6, or 3 times 4. And then out of those factors of 12, what combination of those are going to add or subtract to give me the middle number? Okay, and it turns out this one is only 3 and 4, so I know I'd have to do 3 and 4, and they both need to be positive, so that when I multiply back through there to check my answer when I distribute, the x times x will give me x squared, the x times 4 will give me a positive 4x, the 3 times the x will give me a positive 3x, and the 3 times the 4 will give me a positive 12. And then the two middle terms here do combine in order to give me the 7x. Okay, so that turned out that really wasn't that bad. You just had to think through some things. All right, now when you have that number in front of x squared, it makes it a little bit more difficult. Okay, and if you go to YouTube or if you go to khanacademy.org, okay, or if you just go to Google and Google factoring trinomials, you can find a myriad of videos showing different techniques of how to solve these. But I'm going to go over two of them. Okay, and I'll probably stick with this first way all the way throughout the rest of the examples. Okay, but the two techniques I'm going to talk about, the first one is going to be just guess and check. All right, this is how I learned it. Okay, to me, I like this the best. But you got to do some thinking and you got to be willing to make mistakes and not quit and just keep on going through. Okay, so this is what guess and check does. All right, I got 4x squared plus 5x minus 6. I'm still going to break it down into two binomials, so two parentheses. All right, but instead of having x and x in the front, I now need to multiply to get me 4x squared. So I say, all right, well, what multiplies to give me 4? Well, it's either 1 times 4 or it's 2 times 2. And so I actually have two different options here. Okay, I can either have x and 4x inside my parentheses there, or possibly it could be 2x and 2x. Okay, and I'm not real sure which the correct answer is. Okay, but I'm just going to have to guess and check. Usually I'm going to go with the one that does not have the 1 in it. That's just a personal choice. But let's see. So if this is 2x and 2x. All right, now I'd go about figuring out my last two terms. And just like the ones without the leading coefficient, I look at my last number, 6. It's technically negative. And I say, what multiplies to give me a negative 6? Well, it's 1 times 6. One of those has to be negative, or 2 times 3. All right, and then now here comes the check part. All right, I'm going to try the 2 and 3. Let me put the 2 here and the 3 here. I know one of them has to be negative, but I'll figure that one out in a second if this actually works. All right, and so I'm going to check. Okay, and really the checking part is going to be can we get the 5x by having this combination. All right, and so I take the 2x and multiply it by the 3. That gives me 6x. And I take the 2 and multiply it by the 2x. So if we remember the FOIL stuff, that FOIL acronym, we're doing the O and the I part. Now I'll look at those two terms, 6x and 4x. Is there any way I can get that to be 5 Turns out no. Okay, if I subtract, it's either going to give me 2 or -2, depending on the minus. So guess what? That didn't work. All right. So I got to try again. All right, I got 2x and 2x. Let me stay with that combination for a second. And let me try the 3 and the 2 in the opposite places. Well, you know what? I'm actually not going to try that because it's going to give me the same thing on this one because my 2 here. Okay, so 2 and 3 didn't work with the 2's. Let me try 1 and 6. So if I put a 1 and a 6, the outside gives me 12x. The inside gives me 2x. That is also not going to give me 5x. Okay, so that's not going to work. All right, so what that told me is that, hey, the 2 and the 2 are not going to work. So let me erase my work here. Scratch it out, erase it, whatever. So let me try the other combination. The other way, instead of saying 2x times 2x in order to get the 4, let me try the 1 and the 4. Sorry about that. So 1x and 4x. All right, and now I try the other combinations with the 2 and 3 or the 1 and 6. So let me try the 2 here and the 3 here. When I do that, the outside, 1x times the 3 gives me 3x. 2 times the 4x in the middle gives me 8x. And can that give me a positive 5? The answer is yes. I need to say 8 minus 3. All right, and since the minus is with the 3x, that minus is going to follow up and be right in front of the 3 over here. And the 2 over here is going to have the plus. Okay, so my final answer here is x plus 2 times 4x minus 3. Again, you can always check these problems by going through distributing or foiling, whatever process, and seeing do you get back the original equation or original expression. All right, so that's guess and check. I like that, but it just takes some time to work through it. All right, you have to be diligent and not give up. All right, the other method here, I got the same question, same expression. All right, the other one, for lack of a better word, call this bottoms up method. Or I'll call it the big X. Okay? Now, with this method, there's not going to be as much guessing and checking. All right, but it's going to seem a little magical. Now, with this method, the first thing you're going to do is you're going to draw yourself a big X on the paper. All right? Once you do that, I'm going to underline the first number, leading coefficient 4. I'm going to multiply it by the constant term. So 4 times negative 6 gives me negative 24. And I'm going to put that up top. All right, and then the bottom, I'm going to put my middle coefficient, which is 5. And now I'm pretty much doing what I did in the last section. I'm figuring, hey, what multiplies to give me negative 24 and adds together or subtracts together to give me 5? Okay, and if we know our multiplication facts, this one's not too bad. I realize that, hey, 8 and 3, if I say 8 minus 3, that's going to give me the 5. All right, and so we've done the major heavy lifting here. Now, this is where the magical part comes into it. Once you find those two numbers on the sides of the X, you're going to go back and look and say, hey, what was I multiplying through in the first place? What was that first number? And you're going to take that 4 and you're going to divide it out of both terms. If it divides out like it does with the 8, that leaves me with 2. And you're going to get an equation that's x, parentheses, x plus 2. All right, if it doesn't reduce, or if it reduces and there's still a fraction, this is why it's called bottoms up. The bottom number, the denominator, is going to come in front of the x, and then you're going to say the top number. So since it was negative 3 over 4, we're going to say 4x minus 3. And now we're factored. Okay, so use either method. It does not matter. All right, now let's look at a couple of examples to go through here. All right, example 1, 3x squared plus 11x plus 6. This one's actually not going to be too bad. I've got parentheses and parentheses. All right, in order to get 3x squared, I know it's got to be 1 times 3. So I'm going to put 1x and 3x. All right, in order to get 6, it's either going to be 1 and 6 or it's going to be 2 and 3. All right, I'm going to try the 2 and the 3. I put a 2 here and a 3 here. All right, outside gives me 3x, inside gives me 6x. That doesn't give me the 11 that I'm trying to get. All right, but since the x and 3x were different, I can actually go through here and switch the 2 and the 3. Let me try the 3 here and the 2 here. If I do that, the outside gives me 2, and the inside gives me 9, and those do add up to give me 11 if I put a plus and a plus. So your answer here is x plus 3 times 3x plus 2. All right, without too much wailing and gnashing of teeth. All right, let's look at example 2, see what that has to play for us. All right. Again, starting out the same way, parentheses versus parentheses. All right, this time I need to get an 8x in the front. So that's either 1 times 8 or 2 times 4. I'm going to try the 2 and the 4. I could be wrong, but oh well, I'll just figure it out. All right, but the 5, well, that's just going to be 1 and 5. All right, and if you look a little bit ahead, you can get through this without doing too much writing and crossing out and erasing. All right, that 5 is the biggest number here. I'm trying to get a what in the middle? A 22. So I kind of want this 5 to multiply by the 4 because that's going to be really close. So if I put the 5 there and the 1 there, outside gives me 2x, inside gives me 20x, and that'll give me a negative 22 if both of those are minuses. So minus here, minus there. I double check to make sure that that is going to give me the right sign of 5 at the end. So negative 5 times negative 1 does give me a positive 5. And so there's my answer. I'm done. Okay. All right, same thing here on example 3. All right, there's a minus there with a 7, so we'll take that into consideration. Parentheses and parentheses. To get 2, it's 1 times 2. There's only one combination there, so x and 2x. And to get 7, it's just 1 times 7. Okay, but I do need to figure out, is it going to be a 1 here and a 7 there, or a 7 and then a 1? Okay, so I got to figure out which order that's going to go. All right, and again, I'm keeping in mind I'm trying to get a 13 in the middle. So if I put a 7 here, that's going to multiply by the 2x to give me 14. And the 1 here would multiply to give me 1. And 14 minus 1 gives me the 13 I'm trying to get in the middle. So I put a minus with the 1. and a plus with a 7. And there's my answer. All right, that's what most of these problems are like. All right, now example 4 throws you a little bit, makes it look a little bit more difficult because there's x's and y's. But we saw that in the last section. When we do our parentheses, all right, we're going to have some numbers in here, but I know it's going to be x and y and x and y. I just got to figure out what numbers go with those x's and y's. Do the same thing, 10. It's either 1 and 10 or 2 and 5. I'm going to try the 2 and the 5. And then 3, it's got to be 1 and 3. All right, I'm trying to get a negative 13. And so if I'm looking here, kind of thinking what through here, I got 3 and 2, which is 6. That would make the 1 and 5, 5. 6 and 5 don't give me 13. But if I put the 3 here, that'll give me a 15 xy. And the 1 here, that would give me a 2xy on the outside. And those do subtract together to give me 13, but I need a negative 13. So I know the minus has to go with the 15, which puts the minus with the 3 and a plus with the 1y. And there's your answer. Okay? And you might not get it on the first try. You might have to try a different combination. But that's the guess and check method. All right, example 5. They throw you a little bit more problem because they got x to the 4th and x squared. All right, but no issue here. The only thing that's going to change up is instead of having x and x, we're going to have x squared and x squared. Okay, because the middle term is x squared, and when you double 2, you get 4. So when I multiply x squared times x squared, I am going to get x to the 4th. And then your numbers work the same way. In order to get 3, it's got to be 1 and 3. So 1 and 3. In order to get 8, I've either got 1 and 8 or 2 and 4. All right, let me try some things. Let's see. Trying to get a 5 in the middle. So let me try the 2 and the 4. All right, that gives me 6x squared in the middle, 4x squared on the outside. That doesn't give me 5. All right, erase. All right, let's try the other way around. 4 here and 2 here. That gives me 12x squared and 2x squared. Again, not a 5. All right, so the 2 and the 4 didn't work. So let me try the 1 and the 8. I'm going to put the 1 here because the 8 times the 3 is 24, which is way too big. So we'll try the 1 and the 8. That gives me 3x squared and 8x squared. And that is going to give me a 5. I want it to be a negative 5. So the minus needs to go with the 8. 3 minus 8 is negative 5. So the minus comes up here and a plus in the last one. And we're factored. Now, on all of these, and I didn't note it in the previous ones because they didn't pop up. But whenever you do factor, you want to make sure the first thing you do is factor out anything they all have in common, the GCF. So on this example 6, the first thing I want to do before I do the other binomial times the binomial, see do they all have something in common. All right, 24, 40, and 6 are all divisible by 2. So I can factor out a 2. And they all have at least x squared. So I write 2x squared. And let's do the leftovers. That would give me 12x squared. which 24 divided by 2 is 12. This will give me 20x. It's 40 divided by 2 is 20. I took x squared out of x to the third, leaving a single x, and then plus 3. All right, and then once I do that, now I'm going to work on this inside part. Can I factor that? Okay, so 2x squared is going to be part of my answer. It's just going to hang out there in front. And then parentheses times parentheses. All right, 12. Got a lot of combinations to get me 12. It's either 1 and 12, 2 and 6, or 3 and 4. All right, the last number, 3, there's only one combination there, so I'm just going to go ahead, and since I know it's got to be 1 and 3, put those down there first, and then I'm going to figure out what I need to get the 12 and the 20. All right, so let's see. I'm going to try the 3 and the 4. I put 3x and 4x. 3 times 3 gives me 9. 4 times 1 gives me 4. That's not 20. Okay. Let me try the other way around. 4x and 3x. That gives me 3 and 12. Again, not 20. All right, doesn't work. All right, let me try the 6 and the 2. 6 here and 2 here. Inside is 2, outside is 3 times 6, that's 18. That does give me 20, and they both need to be positive, so plus and plus. There's my answer, 2x squared times 6x plus 1 times 2x plus 3. All right, and then finally, example 7. Okay, I believe this is the last example. If you have a negative in front, all right, what I would do is I would factor that negative out. So the first thing I'm going to do is I'm going to take a negative 1 out and rewrite this as 6x squared plus 13x minus 5. And that's going to make this easier to factor. So if there's a negative in front of the leading coefficient, take out the negative. And then I'm going to work through. To get 6, it's either 1 and 6 or 2 and 3. So negative, and then the parentheses. All right, in order to get 5, I know it's got to be 1 and 5. Since there's only one combination of the 5, I'm going to go ahead and put the 5 and 1. I know those have to be there. And then let me try the other ones. All right, 2x and 3x. Outside gives me 10x. Inside gives me 3x. All right, does that give me 13? It does, but in order to give me 13, it's got to be plus and plus. But when I check, I actually need that 5 to be a minus, so I actually need to have one of those to be minuses. So it looked good, but it actually doesn't work. Got to be really careful. So let me try the other way. Let me try the 3x and then the 2x. All right, so I still got the negative 1 out front. 3x and 2x. That would give me 2 in the middle and 15 on the outside. And that gives me 13 as well. And I can get a minus 2 because 15 minus 2 is a 13. So the minus comes here. The plus goes there. And then negative 1 times the 5 does give me the negative 5 in the parentheses above. So there's my answer. Okay, so that's chapter 6, section 3. I'll post these notes along with the worked out problems for the practice on Canvas as well. Work on my math lab. See if you can get those done. Come to class early next time if you need extra help.